Hey everyone, doing LeetCode and Kotlin. Doing question number 19, remove nth node from end of list. And don't be like me, I was doing this, I read the question wrong and then I thought I was removing the nth node, but it actually wants you to remove the nth node from end of list. So, yeah, so given the head of a linked list, remove the nth node from the end of a list and return its head. So if you're giving this necklace, we want, and then n is 2, you want to remove the nth node from the n. So 5 is 1, and then 4 is 2, so we want to remove the 4. So we want to end up with this node as output. And then for this example, we have only 1, and then you want to remove it, so you return no back to the function as the return value. And if we have 1 and 2 and remove 1, so we remove this, we want to return 1. Alright, so to solve this, it's pretty simple. You can, to solve this problem is pretty simple. We would kind of create 2 pointer and then 1. Because you don't know the size of a linked list, we want to create 2 pointers, and then one goes n steps ahead, and then we loop this pointer, remove this pointer until it reaches the end, and then while we, well, first we move it n step, and then we move it to the end. But when we move it to the end, we also move the pointer that's ahead to the spot as well. So when the fast pointer is at over here, when it's no, we should expect the slow pointer here. So then we could do our magic where we set this value next to the next. So we skip 4 in that case. And yeah, so let's get started. There is one trick that I learned from another YouTuber is to create a dummy node. So that way, if we remove the head, we kind of know that we have like we with the dummy head dot next would equals to no because we set it to no for that case, or at least we remove it. So yeah, let's get started. First, I'm gonna create a dummy head node, and then Kotlin. We actually want to make this to be. Actually, can this be val? Yeah, it can. So we don't need that. I'm gonna try it like this. So we just create a dummy head node with less node of 0, and then we set this dot next to equals to head. So that way we know the next equals head. And then we want to create a var node. I'm gonna call this fast node equals to the existing head, and then slow node equals to would be the dummy head right now. Slope would be at dummy head. Okay, and now we want to repeat n times. So doing this n times, so we are moving the fast node n time. Next. So after we move it n times, so right now over here we put fast node at 1 and 2. Fast node would be at 3, and we have slow node back here, didn't even start yet. And now we want to move while fast node is not equals to no. We want to move it that next move forward until it reach no. So it's gonna move forward 1, 2, 3. And then for the slow mode, do the same. We want to do the same then 1, 2, 3. So we're gonna do slow no equals slow no next as well. Okay, so slow no is now at 3 and then fast no is at 5. And over here we want to set no that next. So 3 we want to set the next to 5. So this actually equals to slow no. Then I could do it that next. So set it to the next variable's next variable. And then we want to return dummy head node that next at the end. So going to run this real quick. Fast node that next. Because it's knowable type and Kotlin is being picky about it. And then submitting this. Cool. It's accepted. Some test cases that I do want to go over a little bit and explain why creating this dummy head was useful. At first, I was like keeping track of it and then doing a bunch of node checking. So if we have a next list with just one, and then n equals to 1 in this case, we want to return no. If we don't have this, um, if we don't have this dummy hit no, it would be very difficult to keep track of it, and you need to uh, do a bunch of checkings and probably create a lot more variables to keep track. Earlier, I had to do I created a slow no, and then I also created a no to delete, and then the slow no was actually no at first, and then I had to do like a check where slow no was equals to no or n, and that the node to be removed next. Um, Also equals to no in order for me to return no. I had to do that to handle that case. And then down here, when I have down here when I was doing the next, I had to like return this if the still no is no, and then the no to be removed have a next, I would have to return it. And um, yeah, it was not the most ideal scenario to do this, and um, so creating the dummy head node definitely helps a lot and solve the problem. Make it a lot easier, and you don't have to do a lot of individual check for these edge case, and it kind of solves it. Yeah, that's all I want to go, and that's why you see a lot of like wrong answers earlier when I was submitting it because of those edge cases, and fix it. And then eventually I used the dummy head no, and then that actually make a lot of things a lot quicker and solve some of the issues that I was having. Um, yeah, thanks again for watching. Hope you enjoyed this, and if you find it helpful, if you please like and subscribe. Thanks.